Welcome to a new lesson of the course. In this lesson we are going to use the PLU Shield board. On this video you can see what I want to teach you in this lesson. Let's connect the PLU Shield board to the main board. By activating the switch buttons you will turn on the LEDs on the board. Additionally, there is an LED that blinks with a frequency of 8 Hz. Create a new project. Name it PLU Shield. Open the file PLUShield.c. Build the project. Let's see first the pins you will use. All pins are on port 0, that's why there is a constant called board I/O port with value 0. The switches S1, S2 and S3 are connected to pins PIO00, 010 and 011. When you move the switch, a 0 will be on the digital input. The switches S4 and S5 are connected to pins PIO04 and PIO013. The switch bar on S6 is connected to pin PIO08. When you press S6, there will be a 0 on the digital input. LEDs D1 and D2 are connected to pins PIO015 and 016. LEDs D4, D5 and D6 are connected to pins PIO018, 12 and 20. The LED D8 is connected to pin PIO014. Let's see the functions board init boot pins and board init pins where pins are configured. There is a structure called IOCON index PIO0SX config to configure the GPIO. Let's see what mean the structure fields. What you see here is the internals of the GPIO. This is the part of the digital output. Now come the internal pull-up and pull-down resistors, the digital input, and the analog input. IOCON PIO mode in act disables the internal pull-up and pull-down resistors. IOCON PIO his in enables the Smith trigger on the digital input. IOCON PIO in DI disables the inverter on the digital input, so when there is a high level of voltage on the pin, the digital value is 1. With a low level, there will be a 0. With IOCON PIO ODDY, the open drain feature is disabled. These features are going to be applied to the digital input pins. Normally, for new projects, PIO00 and PIO04 are always configured as UART. For this lesson, you don't use them, so they are commented out. As on previous projects, you will use the structures output config and input config to configure the pins as digital output and digital input. In the infinite loop, you will get the value of the digital inputs and activate the outputs accordingly. The variable U32S1 value will hold the value of the pin connected to S1. For that, you will use the function GPIO pin read. The same is done for the variables from U32S2 value to U32S6 value. With GPIO write pin output, the corresponding values are set to the digital outputs. You need to use the tilde because when the input is activated, the variable U32SX value is 0, and you need the 1 to turn on the LED. With the tilde, you switch from 0 to 1 and vice versa. In order to use the GPIO on the PLU Shield, you need to make some changes on the main board. You need to open the jumpers JP4 and JP23 to disconnect PIO 014 and PIO 07 from the I2C temperature sensor. Open JP3 to disconnect the GPIO used for SPI, PIO 016, 09, 08 and 01 from the flash memory. Open the jumpers JP21, 22 and 25 to disconnect PIO 011, 12 and 13. Open JP24 and 2 to disconnect PIO 04 and 00 from the debug serial port. Open JP1 to disconnect PIO 011 from the resistor R18. PIO 010 cannot be used because there is no way to disconnect it from the potentiometer VR1, so you need to open the jumper JP8 not to turn on the LED D3. I am going to connect the LED D7 to the output of 8 Hz of the IC74HC4060. Open the jumpers JP12 and JP4 and connect them with a wire. Now you can see again how the program works.